Good morning all. In this video we will be discussing about infiltration. We have already studied what is infiltration. It is defined as the process by which water enters the surface strata of the soil and moves downward to join the groundwater. The infiltrated water first meets the soil moisture deficiency, if any, and thereafter the excess water moves vertically downwards to reach the groundwater table. Consider the soil is dry. It will start absorbing the water, and when it becomes completely saturated, the excess water starts moving vertically downwards to reach the groundwater table. The vertical downward movement of water is known as percolation. Next one, what is infiltration rate? The rate at which the water infiltrates through a soil at a given time is known as infiltration rate. The next term, it is infiltration capacity, the maximum rate at which a soil in a given condition is capable of absorbing water is called infiltration capacity. I will explain with an example the difference between infiltration rate and infiltration capacity. Consider I represent the rainfall intensity Fc, infiltration capacity Fr, infiltration rate. Consider the rainfall intensity, it is 2 cm per hour, and the infiltration capacity, that is a maximum rate at which it is moving to the ground, that is considered as 3 cm per hour. If the rainfall rate is less than the infiltration capacity, the infiltration rate Fr is equal to the rainfall intensity. Consider if the rainfall intensity is greater than Fc. Say rainfall intensity, this is an opposite. Rainfall intensity, say this is 3 cm per hour and this is 2 cm per hour. Then the infiltration rate is equal to the infiltration capacity. If rainfall intensity is equal to the infiltration capacity, then this is equal to the infiltration rate is equal to Fc, or we can say it is equal to the rainfall intensity. I think from this it is clear that what is the difference between infiltration capacity and infiltration rate. Next we will discuss infiltration capacity curve. This is also known as Horton's curve. Consider initially the soil is at a dry condition. When we add water or rainfall occurs, the infiltration rate will be high. Once the soil becomes wet, the infiltration rate start decreasing and it reaches a constant value when the soil becomes completely saturated, and that constant value it is called Fc, that is the final infiltration capacity. This curve can be represented in equation form like this: Fp is equal to Fc plus F0 minus Fc into e raised to minus kT, where F0 represent the initial infiltration rate, Fp represent the infiltration rate at any time, and Fc represent the final constant infiltration capacity. Then K represent a constant that can be calculated using the equation F0 minus Fc divided by F. Okay. What is F? Area of this much portion it is called F, that is for calculating K. For calculating K, we need the value of H. H is the area of this much portion. That is F0 minus Fc by H will give the value of K.